Welcome you all. I am Kavita, working as assistant professor in the Department of Computer Science Engineering. Today I am going to present a topic in Introduction to Operating System. The subject code is CS3451. The topic is Memory Management in Operating System. First, what is memory management? Memory management, which is nothing but it is a function of the operating system that manages main memory. That means random access memory. The memory management is the functionality of an operating system which handles or manages primary memory and moves process back and forth between main memory and disk during executions. Um, it decide which process get memory, how much memory is given, and when memory is released. For example, when you open Instagram, operating system gives it RAM. When you close it, operating system takes back the memory. So this is the example for memory management in operating system. And why we are using this main memory management. Here's some reason for using memory management. Some of them are it allows you to check how much memory need to be allocated to process that decide which processor should get memory at what time. It tracks whenever inventory gets freed or unallocated. According to it, it will update the status. Also, it allocates the space to application routines. Also, it helps to protect different processes from each other. The objective is efficient use of memory, fast execution of programs, prevent memory conflict, support multitasking. For example, laptop runs in Chrome, Word, Music Player together. So, because operating system manage memory efficiently, so in a Chrome we can use many application at a time. So that is the example for memory management. And what is partition? Partition, which is nothing but memory is divided into different blocks or partitions. Each process is allocated according to the requirements. A partition allocation is an ideal method to avoid integral fragmentation. There is various partition allocation scheme. First fit, best fit, worst fit, and next fit. These are the fits we are using in allocations scheme of partition. In first fit, in this type, fit the partition is allocated, which is first sufficient block from the beginning of the main memory. And in best fit, it allocates a process to the partition that is the first smallest partition among the free partition. And then worst of it allocate the process to the partition which is largest sufficiently freely available partition. And next of it is mostly similar to the first of it, but this fit is searches for first sufficient allocation block from the beginning of the main memory. Next, memory management techniques. There are so many techniques we are using in this memory management technique. Single contiguous allocation, partitioned allocation, paged memory allocation, segment memory allocation. In single contiguous allocation, it is the easiest memory management technique in the method. All type of computer memory except a small portion which is reserved for the operating system is available for one application. For example, MS document and embedded OS. In the main memory management, we have two types of memory management. One is uniprogramming and another one is multi-programming. In uniprogramming, the uniprogramming which implies that only a single task or program is in the main memory at particular time. It was more commonly in initial computer and mobiles. And then the characteristics of a uniprogramming is it allows only one program to sit in the memory at one time. And also multi-programming, which is nothing but an operating system has the ability to execute multiple programs which using for only one processor machine. By using the processor, we can run different types of program at a time. So there are two types of programming. One is contiguous memory allocation, and another one is non-contiguous allocation. Contiguous allocation, which is nothing but each process is contained in a single contiguous section of memory. In this memory allocation, all the variable memory space remains together in one place, which implies that our freely available memory partitions are not spread. Um, if you have the CPU, if the CPU is running, operating system plays when the process is working in the processor, the two or more processor working at the same time. If P1 enters, yeah, it needs 3 MB to process. It only allocate 3 MB for the P1, and then P2 needs 5 MB to use. It allocates P2 to use 5 MB, and then P3 needs 8 MB, means it will partition the memory to allocate and use the resource to work. And then paged memory allocation, which is nothing but this method divides the computer main memory into fixed size unit known as page frames. This hardware memory management unit maps pages into frames, which should be allocated on a page basis. Segmented, which is nothing but only memory management method does not provide contiguous address space. And what is swapping? Swapping, which is nothing but it is a method in which process should be swapped temporarily from the main memory into the backing store. It will be later brought back into the memory for continued execution. It will swap the process and swap the memory to use. Uh, it allows dynamic allocation. For example, if address binding is execution time is being used, then process can be swapped into different location. Else, in case of compile and load time binding, process should be moved to the same location. It almost it is you it helps to get better utilization of memory. And what is fragmentation? Fragmentation, which is nothing but it load and removed from the memory. The free memory space is broken into little pieces. It happens after sometimes that process cannot be allocated to memory blocks considering the small size and memory blocks. This problem is known as fragmentations. If the internal fragmentation, which is nothing but in a memory we can run n number of process P1 allocates some memory, process P2 allocates some memory, process P3 allocates some memory. The remaining block space, which is nothing but the internal fragmentation. And external fragmentation, which is nothing but it reduced by rearing memory cannot content to place all free memory together in a single block. What is paging? A paging, which is nothing but it is a frames. It allocates frames. Paging is a technique that eliminates the requirement of contiguous allocations of main memory. In this method, we can divide the fixed size block of physical memory, that is called as frames. In here some benefits of paging. Paging reduce external fragmentation. It use simple to implement, memory efficient. Due to the equal size of frames, swapping becomes very easy. It is faster to access. And segmentation, which is nothing but it is a requirement of contiguous allocations of main memory. In the main memory, it is divided into variable size blocks of physical memory called segmentation. An operating system maintain a segment map table for all the process. It also includes a list of free memory blocks along with its size. The segmentation memory management works very similar to paging, but here segments are variable length, whereas in paging pages are fixed size. Thank you.